Our next speaker is Kamila Michalowska, and she has written her thesis about the carbon footprint of Brazilian office buildings and investigated options to reduce that footprint. So Kamila, please.
Hi, everyone. Okay, I hope you can see it. So yeah, my name is Kamila, and I'm going to tell you about my master's thesis, which was about parameters influencing the carbon footprint of Brazilian office buildings. In the background, you can see a shading system of a Brazilian office building. And I think it's interesting because it's the main design feature that you can introduce to reduce the amount of energy that is needed for cooling. So first, I'm going to give you some context. Yes, so a fun fact, by 2060, global building floor area is expected to grow by 230 billion square meters. And this is, of course, mainly in developing countries. But how much is that actually? So you can imagine the amount of floor area that is currently in the US, in India, and in China combined. So 230 billion square meters is twice the amount that we currently have in these three countries. So it's an enormous amount of floor area, and we need to take action to reduce the environmental impact of these buildings. And in order to do that, we need to fully understand what causes this environmental impact. In my work, I focused on Brazil, which is the first most populous emerging economy, just after China and India. We expect quite significant floor area additions in the following years. And it's an interesting country because it's a big country and it spans a whole range of cooling dominated climates, which means that by investigating just this one country, we can see the impact of different climates on buildings. And then I investigated office buildings in Brazil. Office buildings is the biggest group of non-residential buildings, and non-residential buildings as a whole have quite poor coverage in building research, which is why it's interesting to investigate them. They also have quite high energy use, especially for cooling. I can tell you that even in such a cold country as Norway, office buildings often need cooling. So imagine how much cooling you need in a country as warm as Brazil. And speaking of cooling, I want to tell you a bit about cooling systems. So you have one main type of cooling system, which is mechanical cooling, also known as air conditioning. In this type of cooling, we have one important parameter, which is cooling efficiency. This basically tells us how efficient our device is in converting electricity to useful work. And then we have another main type of cooling, which is natural ventilation. It's a passive cooling system, which bases on the fact that we let in some external air, which goes through the building, cooling the inside of the building. And in order to let the external air in, we often open the windows. So an important parameter that is related to this type of cooling is window opening effective area, which tells us which share of the window can actually be opened. So, for example, a window that can be fully opened is going to have 100% of this parameter, and a window that cannot really be opened will have 0%, but then we cannot really use natural ventilation there. And then you also have a mixed mode ventilation, which combines these two. So when the conditions are favorable, you can use natural ventilation. But then if the conditions are more extreme and people are not really satisfied with the indoor temperature, you can switch to mechanical cooling. In my work, I focused on these two types of cooling systems in order to compare how mechanical cooling compares with this mixed mode ventilation, because potentially it could offer quite high energy savings and thus emission savings. My research questions were the following. What is the possible range of carbon footprint values for Brazilian office buildings? What are the most impactful parameters? And what can be done to reduce the carbon footprint? The methodology that I used to do that is the following. So at first, I defined some office building archetypes, and including that was a list of 10 variable parameters whose values could differ. And because of that, I needed to select a sample because I couldn't really investigate all the different combinations of these parameters. After I selected the sample, I modeled energy use in these buildings and the material demand of these buildings. Having material and energy demand, I could calculate emissions. Based on the emission results, I could perform sensitivity analysis. And speaking of results, so first I'm going to show you greenhouse gas emissions by city. On the bottom, you have 12 Brazilian cities, and they're ordered in order of increasing cooling needs. And on the other axis, you have global warming potential. And here you have the results. So first, what we can see is that the range of the results is quite wide. So it ranges from 20 to over 100 kilograms of CO2 equivalents. And what we could kind of expect from this graph is that the more cooling you need, the higher footprint, carbon footprint you get. But what stands out here is these three cities, which is why it's because these three cities are placed in one region of Brazil, in the northeast, marked in blue in this map. These cities are placed in a region that is characterized by a relatively bad electricity mix, which means that quite a lot of fossil fuel are used for producing electricity, which is why these three cities have higher greenhouse gas emissions. Here you have greenhouse gas emissions ordered by different parameters. I don't really have time to go into details of all of them, but I want to show you one thing. So here you have the parameter window opening effective area that I told you. And if it's 0, you cannot really use natural ventilation. So these buildings are fully air conditioned. And all the other buildings here have mixed mode ventilation. And what you can see here, that as soon as you allow for some natural ventilation, even if the window opens only by 10%, you have significant drop in greenhouse gas emissions of these buildings. Here you have the results of sensitivity analysis in my work. The coefficients that you can see here, the higher the absolute value, the stronger effect this coefficient has. So we have electricity mixed, followed by climate, cooling efficiency, window to wall ratio, and material lifetime multiplier. So, and what's really interesting here in my results is that both mixed mode buildings and fully air conditioned buildings have the same order of importance of different parameters. So you can see that, for example, electricity mix is the most important for both of them. And to conclude my work, so as I said, the most impactful parameters are the same for both mixed mode and fully air conditioned buildings. Mixed mode buildings offer a significant greenhouse gas saving potential, which is why they should be promoted, particularly if window opening effective area is large. Another thing that we could see is that electricity mix has the strongest influence on the carbon footprint. So mitigation efforts should focus on this parameter because it's going to give the biggest results. This could be done by increasing the share of renewables even though Brazil has quite a lot of hydropower, it's not really enough to cover all the electricity demand. So, for example, wind power could be developed because the potential is quite high in Brazil. And another thing that could be done is to reduce electricity demand, because with lower electricity demand, it's easier to cover all of it by renewables. Thank you.
Yes, thank you, Kamila. So I wonder whether there are any questions from the audience. I have to look through here. I guess it's just 1 o'clock, so some people might be signing off. The shading, how important do you think shading like this is in the future?
So I can show you from my results. Let me just go back. The shading is actually, in terms of greenhouse gas emissions, it's not as important here. It has one of the lowest scores here. But for energy use, it's actually quite significant. I would say it's the most important design parameter that you have. According to my results, I just didn't show all of my results here. So I think it's one of the most important things that we can do to reduce the need for cooling in such warm climates.
Okay, thank you, Kamila. Well, I would like to thank everybody who has joined us. This is only the first in the series of webinars, so I would like to ask you to stay tuned in the channels that you have found out about this. There will be follow-up webinars that we are planning, for example, on the EU Green Deal, on the study on resource efficiency in buildings and vehicles that are coming up. And with that, I would like to conclude today's meeting. Thank you.